Hello, everybody. We're going to talk about distance and coordinate geometry today. Okay, so here we've got a graph. We've got some segments on here. All right, so if we look at segment AB, this is really easy to calculate the distance because it just moves horizontally. I can just count the spaces. 1, 2, 3. This is going to be 3. Oops, I'm not plugged in here. Bear with me while I have technical difficulties. Okay, so this is going to be 3. There we go. Now, vertically, I can also count easily from C to D. There's 2 spaces, so that's going to be 2. The trick comes when you have a diagonal line like this. Okay, how do you count that? So essentially, what you do is you just take this thing and you turn it into a right triangle, like so. And I can count this. This is 3. And I can count this as 1, 2, 3, 4, 5, 6, 7. And now I can use the Pythagorean theorem on a right triangle. If I call this x, then I know that 7 squared plus 3 squared equals the hypotenuse squared. Okay, so 49 plus 9 is x squared, so x squared would be 58. And then, let's see, I would square root that, so that's the square root of 58. Is there a perfect square that goes into 58? I don't think that there is. Let's see, does 4 go in there? Nope, it sure doesn't. So 9 doesn't, 16 doesn't, 25. Nope, that's the answer. So it's going to be square root of 58. So I got to use the Pythagorean theorem. Okay, so easy enough to do. You can do that on any diagonal line. Okay, so find the length of GH. Why don't you pause the video and give that a try, and then come back and see if you got it right. Okay, so what I would do is I would make a right triangle right here. I know that this is 3. I know this is 4. Okay, so we'll call this H for hypotenuse. So 3 squared plus 4 squared equals H squared. You might have this one memorized already and know what it is. This is 9 plus 16 is H squared, which means H squared is 25, which means H is 5. That's the 3, 4, 5 right triangle right there. Okay, so that's easy enough. Okay, give that one a try. Okay, so we're going to go ahead and make a right triangle like so. This is 1, 2, 3, 4, 5, 6 on this side. This is 1, 2, 3, 4, 5, 6, 7, 8 on this side. We'll call this H for hypotenuse. So H squared is going to equal 8 squared plus 6 squared. That means H squared is 64 plus 36. So H squared is 100, which means that H is 10. So this is going to be 10. It's nice that these have come out to be nice whole numbers. All right, I got another one here for you. Go ahead and take a look at that one. See what you come up with. Okay, this one I can go, here and here like this. I know that this is 2. This is 1, 2, 3, 4, 5, 6. Okay, here's my H. So H squared is equal to 6 squared plus 2 squared. So H squared is 36 plus 4. So H squared is 40. Now I'm going to square root that. Now there's a perfect square that will go into 40. That would be 4. It will go in there 10 times. And the square root of 4 is 2. And that's as simplified as it's going to get. So this side would be 2 square root of 10. All righty then. Let's move right along to the distance formula. This is something that I would know until I died, okay? Distance equals the square root of x1 minus x2 squared plus y1 minus y2 squared. All right, this is simply the Pythagorean theorem in disguise. Where does that come from? Right here. So if I want to know the distance from this point x1, y1 to this point x2, y2, I can form what's called a slope triangle right here. Okay? And this side right here is going to be the distance between y2 and y1. So this is going to be y2 minus y1. This side is going to be the difference between x2 and x1. So this is going to be x2 minus x1. This is my hypotenuse. So I use the Pythagorean theorem, and I say, well, h squared is going to equal the one leg squared, x2 minus x1 squared, plus the other leg is going to be y2 minus y1 squared. And then what I do is, we don't want the h squared here. We're going to square root everything. And I get this. And that, my friends, is the distance formula. Okay? Except we call it d for distance instead of h for hypotenuse. So there you go. Very convenient little formula that we can use to find all kinds of answers. So let's take a look at a problem like this. Find the distance between the points 8, 15 and negative 7, 23. All right, so I get out my distance formula. D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So you can label them if you want. This is x1, this is x2, this is y1, this is y2. Okay, so distance would be the square root of negative 7 minus 8 squared plus 23 minus 15 squared. So this is going to be negative 15 squared. This is going to be 8 squared. Okay. 15 squared, that's 225. And it's always going to be positive because a negative squared is a positive and a positive squared is a positive. This is 64. Combine those, that's going to be 289. And of course, everybody knows the square root of 289 is 17. So the distance between them is 17. Came out to be a nice whole number. It doesn't always do that. Okay? So there you go. All right, so it looks like Gidget wants to get in on this. She's been outside the door crying the whole time. She wants to make her mathematical debut today. So here's Gidget. Okay, you go play. And we're going to do math. All right, so now this is another formula that looks kind of familiar to the distance formula. This is the equation for a circle. Okay, x minus h squared plus y minus k squared equals r squared is the equation for a circle when hk is the center of the circle and r is the radius. So this is pretty easy to do. Write the equation of a circle with a center of 1, negative 2, and a radius of 8. Okay, very simple. So you're going to go x minus, this is h and k, by the way, and this is r. So it's going to be x minus 1 squared plus y plus 2 squared, because it's minus negative 2, so it's plus, equals the radius squared. 8 squared is 64. Boom. There's my equation. That is the equation for a circle at 1, negative 2, with a center at 1, negative 2, and a radius of 8. All right, what else we got under here? Okay, you get to write the equation of a circle with a center at 0, 6, and a radius of 10. So why don't you take a second and do that? and then compare your answer to mine. Okay, so we're going to get out our formula. It's going to be x minus the x coordinate here is 0 squared plus y minus 6 squared equals the radius 10 squared. So now we're just going to clean this up. I don't need x minus 0. I just make it x squared plus y minus 6 squared equals 100. And I'm done with that one. Now, you should also be able to go backwards. You should be able to look at this and go, oh, the center of the circle is 1, negative 2, and the radius is 8. Oh, the center is 0, 6, and the radius is 10. Hey, that's what we're going to do here. Find the center and the radius of this circle, with this equation. All right, give that a try. See if you can find it, and then take a look back and see if you get the same thing I did. Okay, this is going to have a center at negative 4, 3. It's always the opposite of these signs. And it's going to have a radius of 9. Okay? It's the square root of 81. Here's another one for you. Ooh, that looks scary, but it really isn't. So give it a try and then compare your answer to mine. Okay, this one will have a center at negative 8.5, negative 3.1, and it will have a radius equal to the square root of 6.25, which that's 2.25, I think. Wait. Bear with me a second. I'm having a brain cramp. So let's see here. Calculator, 6.25 square root of 2.5. That was close. Okay, there's my radius. So, piece of cake. Alrighty, there is your assignment for the day. I will see you guys in class. Have a great evening.